This is a video for the final review in my Calculus 2 class. The directions say to evaluate the integral or show that it diverges. So this is on the topic of improper integrals. Now, with that, we're going to take a look at example 1. Suppose we have the integral from 2 to infinity of 1 over x times the natural log of x dx. Okay? Now, this is the limit as L approaches infinity of the integral from 2 to L of 1 over natural log of x times 1 over x dx. So this is the limit as L approaches infinity of, I get natural log of x evaluated from 2 to L. So this is the limit as L goes to infinity of natural log of L minus natural log of 2. And this is equal to infinity. And so what that tells me is that the integral from 2 to infinity of 1 over x ln x dx diverges. Let's take a look at example 2. Suppose we have the integral from 1 to infinity of 1 over 2x plus 1 to the third dx. So we can write this as the limit as L approaches infinity of the integral from 1 to L of 1 over 2x plus 1 to the third dx. Now, this is the limit as L goes to infinity of the integral from 1 to L of 2x plus 1 to the negative 3 dx. Now, here's my question. Isn't the derivative of 2x plus 1 2? So if I put a 2 here, I need to multiply this integral by a half. Okay? And why did I do that? Because if I let u equal 2x plus 1, my du is 2 dx. And so in my mind, I'm integrating u to the negative 3 du, if that makes sense. And so here, I'm going to pull the 1/2 out in front. I'm going to get the limit is L goes to infinity of, I'm going to get 2x plus 1 to the negative 2 divided by negative 2 evaluated from 1 to L. Now, if you don't mind, I'm going to pull that negative 1/2 out in front, and I get negative 1/4. The limit as L goes to infinity of 1 over 2x plus 1 to the second, evaluated from 1 to L. Now we're going step by step. And so here, this is negative 1/4 the limit as L goes to infinity of. Now I'm going to replace x with L. I get 1 over 2L plus 1 to the second. I'm going to go minus, and then I'm going to replace x with 1 and get minus 1/9. But as L goes to infinity, this first term goes to 0. And we get negative 1/4 times negative 1/9. The answer is 1 over 36. And what this is going to tell me is that the integral from 1 to infinity of 1 over 2x plus 1 to the third dx is going to converge. So this integral converges because we got a fixed value back. We're going to do one more example for this video here. Let's take a look at example 3. And suppose we have the integral from 1 to infinity of arctangent x divided by x squared dx. This one's good. So I'm going to write this as the limit as L goes to infinity of the integral from 1 to L of arctangent x divided by x squared dx. Now, if this is helpful, all right, if the limit gets in the way, we can do this. We're going to let a of L equal the integral from 1 to L of arctangent x divided by x squared dx. We're going to figure out what a of L is. So a of L is going to be written in terms of L, of course, right? And then we'll let L go to infinity from there. So I'm going to let U equal arctangent x. dv is 1 over x squared dx. du is 1 over 1 plus x squared dx. And v is negative 1 over x. So this is negative 1 over x arctangent x evaluated from 1 to L minus the integral from 1 to L of negative 1 over x times 1 plus x squared dx. When you subtract a negative, you're going to add, okay? And on top of that, I'm going to evaluate. So I get negative 1 over L arctangent of L plus arctangent of 1, okay? Minus a negative is a positive. Plus the integral from 1 to L of 1 over x times 1 plus x squared dx. From here, I'm going to take 1 over x times 1 plus x squared and get, by partial fractions, a over x plus bx plus c divided by 1 plus x squared. So my LCD is x times 1 plus x squared. So 1 equals a times 1 plus x squared plus x times bx plus c. So 1 equals a plus ax squared plus bx squared plus cx. So for my x squared equation, I get a plus b equals 0. For x, I get c equals 0. Okay? For x to the 0, the constant, I get a equals 1. And if a equals 1, that tells me b equals negative 1. So it's a really nice result here. Okay? So from here, a of L equals, now let's go back. We get negative 1 over L, arctangent of L, and then this is pi over 4. So we get pi over 4 minus 1 over L, arctangent of L. Then I'm going to go plus the integral from 1 to L of. Now let's go back. A is 1, B is minus 1. So we get 1 over x minus x divided by 1 plus x squared dx. Remember, c happened to be 0. So it works out really, really well. Now, from here, we get pi over 4 minus, and then this is 1 over L, arctangent of L, plus, then I get natural log of x minus, this turns into 1/2 natural log of 1 plus x squared, okay, evaluated from 1 to L. There's a little bit of work here as a massive heads up, okay? Now, this is pi over 4 minus 1 over L, arctangent of L, plus, then if I pop the L in, I get natural log of L minus 1/2 natural log of 1 plus L squared. If I replace x with 1, natural log of 1 is 0. And then we get plus 1/2 natural log of 2. Okay? Now, we have a property of logs for these two guys. So it's tricky. So this is pi over 4 minus arctangent of L divided by L. And then I claim I'm going to write this as natural log of L divided by the square root of 1 plus L squared. Okay? And then I'm going to go plus 1/2 natural log of 2. Now, I claim as L goes to infinity, this guy inside the natural log is going to approach 1. Make sure we're okay with that. Okay? Now, from here, I'm going to get the limit as L goes to infinity of A of L. This is the limit as L goes to infinity of, I'm going to get pi over 4 minus arctangent of L divided by L. Then I'm going to go plus, and then I do natural log of L over the square root of L squared plus 1. Natural log of L over square root of L squared plus 1 plus 1/2 natural log of 2. Now, I also claim as L goes to infinity, right? Arctangent of big is going to approach pi over 2. So this second term is going to go to 0. Okay? And so this is pi over 4 minus 0 plus natural log of 1 plus 1/2 natural log of 2. And you're going to get a fixed value back. Natural log of 1 is 0. And so what this tells me is that the integral from 1 to infinity of arctangent x divided by x squared dx converges. And that'll conclude this video. The topic is on improper integrals, and we did 3 examples. And I would encourage you, if you guys go through the video, pause the video on the problem, try the problem, and then check out how I approach the problem. It might help you when reviewing. Okay, thank you.